recorded, and so it will be available for anyone who would like to attend after the fact and or review any questions that have been asked. So welcome again. Can everyone hear me? Just want to check. Great.
Yes, I can hear you.
Great. Thanks, Bob. Thanks, Alex. So yeah, once again, thank you all for joining. We have several representatives from Moog and from Bosch Rexroth. We have myself, an assistant engineer in EB Mud. We have Angela Ralston and Becky Sharp, who are a part of the purchasing and procurement team at EB Mud. And we have Bob Kirby and Alex Belica from who are the technical consultants on this project. And I'll let Alex take it away from here. I believe you're muted, Alex.
Yeah, to start, I will bring up the presentation here. And I just wanted to go through a couple slides. I know most of you are just not doing it. Oh, shoot. Sorry, bear with me. I've got two screens going. Okay. I think we'll just have to do with this then. Can everybody still hear me? I didn't lose everybody.
Yes.
Okay, great. So this is Breonas Reservoir. As you know, there's a tower. I think you can see it just a little bit right here in the middle of the reservoir. And inside there are a series of seven different 60-inch butterfly valves at different elevations. And this is an aerial view of the tower in the middle of the reservoir. The nearest shore is about 800 feet away, and that is where the electrical controls will be for those valves. The concept is to have a control shed on that shore that we showed just a second ago, and then we'll run electrical lines down along the reservoir bed, and then up along the tower, and then punching through the wall of the tower to get to the valves inside and the HPU that will be located at each elevation. I guess this is probably a good shot here, but again, this is just a zoomed in view showing the tower, and the individual lines will be coming off here. So this is going to be a bundle of cables, and with each one dedicated to the valve and its HPU associated with it. And then lastly, I just wanted to show this. I know that we have detailed drawings of in the bid package, but just wanted to kind of give an idea of what our concept was, is that there's an existing linear oil-filled cylinder that strokes a butterfly valve, and that will remain existing. And the idea is that this submersible HPU shown in this box would have an electrical connection, and then it would cycle the valve as needed. And there would be one of these for each of the 7 locations located near the valve. There is an 8th spare HPU that is part of this procurement as well. And then lastly, I wanted to show a picture of the tower here. As you know, this is what it was like in construction, so you just get a feel for it. So there's no valves on the outside. It's all internal to the tower. Why don't I guess we could jump into this, but let's start with the layout a little bit more. So these are the record drawings that were included in the bid RFQ. As you can see, this is the inside of the tower here. There's a ladder down. The flow goes in through those entrances at various elevations. And our idea was to put the HPU at about right here at each of the elevations. And then of course, the piping is going to run, any kind of piping for maintenance and whatnot is going to occur, is going to run along this vertical stretch inside the tower. And then there's going to be a maintenance console that's outside of the scope of this RFQ. But it will allow maintenance to flush the fluids in the HPU and stroke the valves in emergency situations. And so last, I guess here is just your typical butterfly valve with a sort of link and lever actuator. It's not showing the hydraulic cylinder up above, but it's basically just bolted directly on there. So this is the inside of the tower, as we were talking about earlier. This is the location of the HPU, and it would be fastened to the inside wall of the tower, is the idea. And then the piping and the installation from the HPU to the other components would be by a third-party contractor, as well as the commissioning. Okay, so I guess as part of this, you know, we were hoping for some, I guess, giving the vendor some ability to influence the design, you know, based on their experiences. And this submersible HPU is, we're trying to convey what we want, but it would be great if you guys could, you know, propose something that was better, or if you have improvements, that works as well. But essentially, we have a reversible motor is our original concept, where you, if you want to stroke the valve one way, you turn on the motor. If you want to stroke it the other way, you flip the polarity back at the shore and run it in the other direction. There would be pilot operated check valves for maintaining position when the motor is off. And then also we definitely want some kind of pressure feedback on the two ports going to the valve, just like they have out there now. And then we don't really have a good way to get the position data off of the existing valve. So the concept was to either do a some kind of flow switch in line with the pressure lines, so that we could see when we reached a full dead stop, or to use some kind of encoder on the motor for just monitoring revolutions. And then I guess a couple other features here. There is, we have two additional lines coming in that we wanted to connect up to the HPU, such that if the HPU cable or something happened, it would be able to be operated from the top of the tower. And then also this line here would allow it to be flushed after the piping is hooked up. You know, you'd use this cross tie valve, and you'd block out these two valves, and you could stroke the cylinder and, you know, flush, and then run the fluid flushing it in one direction, stroke the cylinder, run it in the other direction. So that was kind of the concept. But we want some way of flushing this out simply for the contractor. And then lastly, there's this oil fill and drain lines. We wanted maintenance to be able to fill and replace the fluid as necessary for your maintenance schedule. There are some other lines coming off of the valve itself. This remains outside of the scope, and you don't necessarily have to worry about it. But one of them is a gearbox oil line going to each of the actuators, and then there is a couple other lines for position and going to the top of the tower, as well as the greasing for the bearings. With that being said, just a quick review on the bid requirements for the vendor. It will require design, manufacture, shop assembly, testing, packing, and shipping of the 8 HPUs. The delivery date is June 1st, 2020, and shop drawings would be due 60 days after issuance of a PO. I believe that this includes some field services, and I think that's in the bid as well. There is an alternate as we were talking earlier, sort of along the lines of the encoder, is using a variable speed pump, which can be proposed as well. And that would be nice, that we could actually vary the speed of the cylinder instead of being, stuck with whatever we have once it's installed. The voltage is 240/120 AC, 3-phase, and I think that's mostly what I had in my list of requirements here. So there's much other items, but I guess we should just open it up for any questions or concerns we want to talk about.
Thank you very much for the overview on the technical aspects and the project as a whole. I just want to clarify one thing. The schedule was for 2022 for the delivery date, just so that we have that and don't cause any confusion. Right. So now would be a great time for questions that you may have, and we'll do our best to answer what we can now, and other items that we don't have the answers to immediately, we'll make sure we'll note them, and we will respond to them as soon as possible, but no later than the date at which addendums are due, as listed in our RFQ. So I think our group is small enough at this point. If you would like to either raise your hand and I can call on you to ask your question, or you can also type it into the chat box if your microphone isn't working. All right, I'll start with Milan. If you can unmute yourself.
Yeah, hi guys, hello. Good morning. So I have a few questions, and I guess the first one is the tower itself. In the tower, would the tower be filled with water at all times, or only when the valves are open? So what I'm basically asking, are those power units going to be under the water at all times?
I think the answer to that is yes. Bob, correct me if I'm wrong there. Well, the upper ones, I don't know, John. Are they always submerged?
It depends on operations, and so there is a possibility that if the reservoir remains full, that all of them could be submerged. But particularly for the upper ones, if reservoir restrictions are applied, some of them may remain above water for extended periods of time. So we need to be able to be flexible on which state they're in.
Okay. The next question is regarding the existing cylinders. They're obviously installed from wherever the valves are installed. So we assume they're in operational conditions. So would they be checked prior of installation of the power units to make sure they're fully operational? So we just have assumption they're working, right? We don't really know that, do we?
That is, I want to, oh, did you want to speak, Alex?
Why don't you go first? It's a larger question, but it's a good one.
I believe for the purposes of this RFQ, and correct me if I'm out of order, that is not the functionality of the existing valves is not the scope of this RFQ, and so that is the fair assumption for your product that you'd be providing, that they are working.
And John, this is Bob. I might add that the district exercises these valves, and it's my understanding that as of the last time they were operated, they went through the operation of the valves. Indeed, they were working. I mean, the valves are operable now. They open and they close using the existing equipment that's there.
Okay,
yes.
Thank you. Just the last question from my side. So would these submerged power units be the primer drive or the main hydraulic power unit that sits on the current hydraulic power unit will be the main drive, and submerged ones will be used in case of emergency?
It's the submerged ones are the primary. The ones you're going to be providing or that the vendor is providing is the primary. And the ones at the surface would be secondary.
Very good. Thank you very much.
Great. Kenneth, if you can unmute yourself now, and Milan, if you can mute yourself again.
Yep. Hello. On your spec, when I saw that, I saw the requirement for certification to the NSF ANSI specification. We're researching that now, but I do not believe we'll be certified in time for the submittal. Is that going to be an issue?
So for the purposes of making sure everyone is clear on the question, the reference is, I believe, in the RFQ
Yes.
section D, page 4, where materials in contact with drinking water are required to be certified according to NSF or ANSI 61. Whether or not, so to directly answer your question or attempt to answer your question on whether or not the not having the certification in time for the bid due date, we would need to review in-house the expectations and whether or not that would pose a problem for the bid package itself. So that would be something we can try to address following this meeting.
Okay.
And thanks for that question.
Yep.
Kind of in parallel with that, we will also need to then be looking at the interpretation of how the NSF standard and expectation is applied for the materials in the bid requirements. So.
Okay. Do you want to provide a range of scenarios that this outcome could be? And or
Sure. The one, and this is not a comprehensive list of what could happen. So full disclaimer up front. One possibility can be that that the standard primarily applies to the materials, as written in the RFQ, and so the final product itself, as a package, doesn't necessarily have to have the certification, before
Okay,
it's made. That might
okay.
be one possibility. Another possibility could be or expecting and planning to have that product certified after it is designed. And so I currently do not expect that not having the final product certified at this moment, because it doesn't exist yet, should be a disqualifying factor.
Okay. Yeah, and that's the other part. Oops, sorry. Is where it says what's the actual parts that are in contact with the water, because actually it's all encased in the outside. So there's only actually a small part of the assembly that's actually in contact with water.
That is an excellent point.
Yeah.
And so, in accordance with what is written in the RFQ, the parts that are in contact are at this point, it should be certified. So.
Okay. My other question on a similar one is you had reference about experience with subsea or subsurface applications of 200 feet or greater, and examples of that have been out in the field for 10 years. There is a number of products we can give references to, but they're a little bit different. They're not the exact same because it is a new product. So if we show a number of examples of various electrical mechanical stuff that we have subsea experience with and deployed for a number of years, would that meet the requirements?
I think so.
Okay. The only see my other in your just for clarification, when you mentioned the working fluid, you mentioned the Petrochem 46, and then you had a comment about dielectric fluids. Would there be an issue with just using, like I said, if we use an environmentally friendly fluid like a Panelin environmentally friendly fluid, could that, which is a dielectric, could that be used for both the dielectric and pressure compensation fluid and also the working fluid to the actuator?
I would say, assuming that fluid is approved by the district, I would be okay with using this one and the same on both.
That way there's no chance of mixing fluids and trying to come up with a barrier system between the two systems.
Yeah, I think when this was written, it was, for any dielectric fluids. So if dielectric fluids were present, in addition to the working fluids. So yes, it can be one and the same.
Okay. And you had mentioned just a little while ago about encoders to monitor the revolutions of the pump. Would resolvers be acceptable?
Yes, that'd be good as well.
Okay. I think that's my questions for the moment. If someone else has questions.
Thank you very much. I don't see anyone else's hands raised at the moment. And so if no one has any further questions, Bob and Alex, if you have any closing comments that you'd like to add in following all these questions.
I guess I did want to note, it can be lost in the spec a little bit, but you know, in addition to powering these valves open and closed, we were to some degree trying to mimic the existing dry pumping system that's out there now, and the design of that allows for when you're closing against a higher flow, or you know, when you're trying to close the valve against flow, which is a rare occurrence. There is a throttle valve that in the system, in the oil system, that will decrease that flow, because once you get past about a 5-degree turn on the valve, it's an automatic closing valve, so it'll, you know, pressurize that oil cylinder. So just didn't want that to be lost in the complexity of the mechanism. The other item is the housing itself is, you know, the wall on the inside that it would mount to is curved in 2 axes. So you've got it, you know, curved as if you're looking downward at it, because it's a cylindrical tower, but it's also a conical shape too. So those were pretty much my 2 other items that I wanted to make sure that we got out there. So.
All right. And Bob, anything that you'd like to add?
No, I don't think so. I think Alex has done a very good job, of course, of designing this and covering the items. So if other questions come up, John, I presume we'll be accepting those and responding to them in due course. And as I think you mentioned at the start, you may not wait until the final date to issue answers to questions. You may release answers, you know, as you go. But certainly you'll answer questions by the final date that's shown.
To the best of our ability, yes, we will try to keep the process moving. Ken, I see your hand is up. Was it raised again, or?
Yes.
Okay.
Just on something that Alex just said about the curved surface where this HPU will be attaching to. So is that part of the scope of supply that we would supply the brackets to attach our assembly to that? And if so, do we have all the details of what we have to attach to, or where we need to attach to?
I would have to look at the spec.
I was glancing through it. I didn't just when you mentioned that, just caught me. I didn't happen to see if that was.
We have welded lugs with anchor holes for mounting the HPU to the wall, so I'd say yes.
Okay.
And perhaps we certainly could say that during the project, you know, Alex will be working and available to consult with the vendor, the successful bidder. And one of the things we will certainly do is provide you the details of the shape that you have to attach to. It's a circular, a tapered circular surface, but the taper is very small. I don't think that it's going to be very much of a challenge to figure out how to adjust the brackets to account for the slope. And in fact, it's not even clear to me that it would require much adjustment, Alex. It depends on the size, I suppose, of the unit compared to the variation in the tapered size of of the tower, but we can provide all that geometry information to you.
Thank you.
Fantastic. If we, oh, Milan has another question.
Oh, it seems the two of us are guys with the questions. So just on part of the scope of supplies is a hydraulic cylinder that will be used to test the units and then supply the cylinder with the units. Would you accept the metric version? Because right now the imperial dimensions are specified. So the question is, would you accept the metric version, or it has to be imperial? I mean, metric equivalent, let's say.
Yeah, I think we would accept that. Yep.
Thank you.
All right. And it looks like we have going once, going twice, no more hands in the air. All right. Well, thank you very much, everyone, for attending this video conference. We will post the recording and as soon as we can, and respond to the questions accordingly. So thank you very much for your time. If you have any further questions, you can always reach out to the email listed in the RFQ. And we look forward to seeing your bids shortly. Take care, everyone.
Thanks.
Thank you. Have a good day, everyone.
Thank you. Bye now.